Let's go. I'm here today to explain how you can publish 1 million, 1 million of message to SQS queue or whatever the message queue solution you 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 like to use. But I will use SQS here. Um, this challenge, the idea is use Node.js in JavaScript to publish 1 million of messages into the queue in 5 seconds. Okay, and I can show how you can deliver this. For a lot of people, is a huge volume. For other people, is nothing. But 1 million, in my opinion, is a challenge number, and you need to do a lot of stuff in Node.js to deliver this in 5 minutes. So my idea here is present all these techniques I use it for you, and I believe can be helpful for you if you don't know these techniques. Okay, now I go to VS Code. This is the code. If you notice, I have a lot of files here because I have different versions, and each version is a one challenge because this video I record here, I record a lot of videos, a lot of challenge, show how you can publish 1,000, 10,000, 100,000, a half million, 1 million. I record in Portuguese. I believe the YouTube have generate the translations, the subtitles in English. If you are not and if you don't speak Portuguese native, I recommend you enable subtitles. There, these videos can have helpful information for you if you're working as a JavaScript developer, Node.js developer. So, but let's focus here. I have this method here called process message. I call here in the bottom. So here what I do, I have a loop. This loop will interact one, one, 1 million times, 1 million times, and each interaction I will call the push method to add a new item, where this new item is a JSON. This JSON has a true is an email address, who is received this email. To give a context, imagine you need to publish 1 million of emails because you you work as a developer from an e-commerce platform, and you need to send 1 million emails about Christmas promotions. So this is why I use this example. And you need a solution to deliver this the scalable way, because imagine the e-commerce company need to send this one day before the Christmas day. So you need create a solution, a scalable solution to deliver this in the right time. In this case, one day before the Christmas day. So here I add a new item. This item has this content. In a real scenario, I know is different, can have more information, but for this example is great. And here, all times I check if the size of the array is equal 200. If the message array, the message list is equal 200, I go for this block here. What I do here, I call the SKS SDK, and I call the method named send message to send a message for this specific queue, and the message body contains the 200 messages So imagine I send this message for SQS. One message contains 200 items inside. And what is the benefit? Uh, what is the benefit of this in this strategy? The benefit is instead I send 200 message one by one. I send only one message, so I reduce 299 requests. So I prevent 299 requests. So I prevent the latency. The latency is a time to interact, send a request for the server and receive a response. So I prevent this. So this is why I put 100 items in one message. Another important stuff. Here, after look my scenario, I noticed this JSON multiplied by 200. The size of in bytes is less than 256 kilobytes. And why 256 kilobytes is important? Because the is the limit size it message on X the is the limit size the SKS one SKS message can have. Okay, so you need to take care about this. If your JSON uh, JSON data is bigger, you need to consider you need to calculate how many bytes each item spent, and based on that you can understand how many items you can put inside one message. And to do that you can do stuff like this. You can access this website here where you can put your JSON in this block here, and and this and this site will give you the size in bytes, and can I believe can helpful for you understand. Okay, it item has 100 bytes. So how many items I can and you can do a simple math to understand how many items you can put in one message. Okay, back here. After that, what I do here, if you notice, I don't use the keyword await here. And why I'm not using the keyword await here? Because my idea is not block my code in this line here. I add this promise, this operation is I add this promise in this promises send message list, and after this promise send message list length is when this promise send message the length is when the promise when the size of the promise send message list is equal was equal for I use this method here promise.all. What is this? Is a technique used named task in parallel in Node.js. Node.js is not blocking IO. So this request here to send a message for SQS queue is a IO operation. And if I put the await here, the next line here, this next line here, need to wait this operation return a response. So I block the execution. And my idea is not no block the execution. So I accumulate this. This is why I call the method push here and add this promise in this list. And I check this list. The size now is equal 4. If not, go back to go back to the top and do the same stuff I explained it before. And the moment they check again and the size of this list is equal 4, I do the promisal here, and I make the all code wait this promisal finish to continue the execution. So that way here I put 4. So it's like I have a operations, IO operations in parallel, execute in same time. That way I can improve the speed to publish this 1 million message on queue. Here, after out the loop block, I have these two ifs here. This first if is to guarantee if don't have items on messages list. If have some item inside, I do the same operation. I explain it here. Okay, and I checks if the promise send message list has some content. If have some content, if has some content, I call the promise all and I put the keyword await here before the promise all. So that way these two ifs here is to guarantee I will publish all message to a queue. And I don't that way I can prevent left some message, some items without sent for the queue. Okay. Okay. I explained about why I send 200 items to reduce the how many operations I will to reduce the requests I will send for SQS, and I prevent unnecessary requests. I explain about process in parallel is another strategy. The one strategy I need to explain here is a HTTP reuse HTTP connection. I believe you can agree with me. All times I call this method send message, I send a request under the hood. The AWS SDK, the AWS SDK send a message, a HTTP message for SQS API. And all times I open the HTTP connection, and after I receive a response, I close the HTTP connection. To improve this part, you can do what? You can create called the HTTPS model is a native model on Node.js, and I can use this in this instruction here. I'm saying keep the HTTP connection open. Don't close the HTTP connection after receive a response. And I set this agent here in AWS SDK. That way, I can reuse the HTTP connections, and I can improve the speed because I don't need to reopen the connections all time. Okay, is another strategy. The final strategy I did for this script here is here. If you notice, I have a SKS. This SKS I created on North Virginia region, okay, and I create the EC2 in the same region. Why I do this? I read. I can put the link on description. I read a AWS documentation explain if you put the EC2, the application response to publish message on SKS in the same region of the SKS queue, you can reduce the latency. Is a is the last strategy to improve improve your script to publish the message on queue. So you can reduce the time to deliver the message to queue on SKS. Okay. Now I explain the script. I talk up a lot of stuff. So it's a moment to show how this work. Let me show here. Here I'm connected is a I connected via SS8 in this instance here. Now I I prepared this script. So the only thing I need to do here is called node.js dot src producer v6 and press enter. Now I start to send the message for this queue here. If you notice, let me reload again. I have more than 2,000 messages here. The message available, this column explain how message the queue has. Okay, and to base this strategy I presented, 1 million message divided by 200. 200 is a total items I put in it message. So I need to have 5,000 message on queue. Here I have 5,000 messages. So now let me check. I spend 16 seconds. Let's consider 16 seconds. Less than 1 minute to publish 1,000 messages. Of course, if you have a scenario where your JSON it JSON item you have is bigger, probably the items we will put in the inside the message can be less than 200, but you can have the same benefits. The benefit I had doing this approach, but for if you have a big JSON, like I said, you need to publish 1,000, and the number of items inside the message is less 200, probably can take more time to send this 1 million message to queue, but probably you can deliver this less than 5 minutes. So that's it. This is the the video. The idea behind the video is explain this approach. Is if you read about, probably is an uncommon approach, has a side effect. The side effect you will face in a consumer part, but I will do a exclusive video about the side effect in the consumer part. But the focus the focus in this video here is talking about publish the 1 million. So that's it. The side effect I will talk in the next video. One point I forgot to say is I use the t2 This instance has one CPU, one vCPU, because EC2 is a server. The server has virtualization, I believe. So this I publish 1 million messages using uh, EC2 instance where this instance has only one core. So I believe it is an important point to say. So instead you have a machine use many cars and split this demand between many cars using, for example, the cluster model from Node.js. Use this approach where I put a lot of items inside one message. I can complete this task uh, less than 1 minute. Use the EC2 instance, has one vCPU only. So that's it for today. Um, I forgot. I forget something. I remember. I remembered. Here, this strategy I explained it in this video is inspired by this talk about the Duolingo, this talk where the developer from Duolingo, a software engineer from Duolingo, explained the challenge faced by Duolingo, where the Duolingo needed to send 4 million of push notification in 5 seconds. So the software engineer explained it, this approach where one message, these guys put one man put a lot of push notification tokens inside one message to allow them to uh, complete this challenge. So I recommend you to watch this talk. I put the link on the description too. Is interest this talk after listening this talk I learned a lot. One thing I learned is this strategy where one message I put a lot of items inside this one message. So that's it. I hope I hope I hope this content uh, will I hope this content can be I hope this content can be helpful for you. So, see you soon, my friends. Bye bye.